Hello, wonderful students. All right. So today we're going to do more in depth of making word problems for quadratic functions and writing the equation from a word problem. So far what we've done is I've given you a point, I've given you the vertex. You were able to solve for A and find your equation, and you go from vertex form to standard form, so forth and so on. But this time I'm going to read you word problems or give you a graph, and from there you should be able to interpret and write your equations. So, what we did not do last class is we did not go from vertex form to standard form. But from standard form, you should be able to find your vertex. You can, yes, graph this on Desmos and find your vertex this way, or again, guys, please remember that a lot of your SAT, when you do take the SAT, there will be a non-calculator section. And knowing how to do this by hand, because algebra is very heavy on the SAT test. So just remember that's why we don't just rely on our calculator. So how do I find the vertex? I use this formula to find the x value, negative b over 2a. Well, that's not difficult because I can find my A, B, and C and utilize that. And this is on the formula chart, so it's not something you have to memorize. So my A value for the standard form is what? 2. What's my B value? 8. And what's my C value? Negative 9. So I identified this. Now let me use my equation. Negative b over 2a. So negative b, 8 over 2a. 2 times 2. 2 times 2 is 4, so negative 8 over 4, is negative 2. So here's my x value. But I want to find the vertex. Remember, the vertex is a specific point on your parabola. So I also need the y value. So if I have the x value, what do I do with my equation to find my y value? That's right, I plug it in. I just have a feeling people were saying that, right? Because at this point, we know. We substitute back in. And remember, you can put this whole lot right here into Desmos. Negative 2 squared is 4, so 2 times 4 plus 8 times negative 2 minus 9. 2 times 4 is 8. 8 times negative 2 is negative 16 minus 9. 8 minus 16 is negative 8 minus 9, so that would be negative 17. So this has a vertex at negative 2, negative 17. Here's your H and your K. I'm not going to spend a lot of time on that because that's literally just plugging in the A and the B, plugging back in the X to find your Y value, okay? And I know that at this point we're masters at substituting in and following formulas. But what if I want to write an equation from a graph? So I'm giving you a graph. Let's point out some features on this graph, shall we? Is this an upward facing parabola or a downward facing parabola? Upward facing. So what does that tell you about the A value? You know your A value should be positive. HK, what does HK stand for? Your vertex. Well, what is the vertex? The minimum or the maximum. And this is at 2, 3. And how do we label our vertex? HK. All right. And to find our equation, what else do we need? We need the A value, but we can't just figure out the A value by looking at it. We have to solve for it. So I need another point on my line. I personally like using the y-intercept. So there's my x and my y value. Now that I have all of that from last class, we should be able to plug all that in and find A. So y equals A, x minus h squared plus k. My y value we found is 7. I don't know A, that's what I have to solve for. The x value is 0. The h value is positive 2, so 0 minus 2 squared. Plus k, my k value is 3, so plus 3. So PEMDAS order 0 minus 2, negative 2. Exponent next, negative 2 squared is positive 4. Solving, subtract 3 from both sides. That will give me 4 equals A times 4. Divide both sides by 4, A equals 1. So my equation would be y equals 1x minus 2 squared plus 3. Why did I not put that 1 there? It really doesn't matter, right? Now how do I go from vertex form back to standard form? I need to simplify this. So x minus 2 squared first. Remember, x minus 2 squared is x minus 2 times x minus 2. So x squared, negative 2x, positive 4. So x squared minus 4x plus 4. So that will give me y equals x squared minus 4x plus 4 plus 3. Combine like terms. Y equals x squared minus 4x plus 7. So here's my standard form. Here's my vertex form. So I really didn't do anything differently that we did last class except use a graph. And just, instead of it telling me the point, instead of telling me the vertex, me just finding those things. Okay, and if you didn't get all that, pause the video, rewind it. Now let's look at a word problem. This video is very short compared to what I usually do, because I usually make a Nearpod, and it takes most of class to actually do the whole Nearpod usually. If you watch this video and you still didn't grasp it, I'm going to leave the Zoom recording from last year up on Canvas, so feel free to go look at that, which is much longer, deeper explanation, other students asking questions, so forth and so on. A basketball was thrown off a 30-foot roof. My suggestion, you always draw a picture, okay? So let's say here's a building. Okay, let me start over. That was not a cute building. All right. Here's my building. I know that my building is 30 feet high, okay? And here I am standing, and I throw a basketball off the roof. So you know the projectile will look something like this. It reached a maximum height of 35 feet. So I know that it reached a maximum height of 35 feet. So here's my maximum, 35 feet at 2.5 seconds. So time is usually your independent variable. So at 2.5 seconds, it was at 35 feet. Write an equation that represents this problem. I want you to notice some keywords here. Maximum, maximum, maximum. What represents the maximum on a graph? The vertex. So it gave me my vertex. It told me at 2.5 seconds, it was at 35 feet, right? And remember, time is independent. So that's why I put the time first. And the height here is your y value. Oh, I made a mistake. Anyone notice what mistake I made? I labeled my vertex x and y, but how should I label my vertex? H and k. Now, I need some more information. I can't write an equation from just the vertex. What else do I need? I need another point. Let's reread the problem and see if we can figure out what the other point is. A basketball is thrown off a 30-foot roof. Okay, I see 30. But what else? At what time was that basketball thrown off that 30-foot roof? At 0 seconds, right? This would represent my y-intercept. At 0 seconds, the basketball was thrown off a 30-foot roof. So my other point, the point that it gave me, is 0, 30. So I'm going to label this x and y. So now I have all the information I need to write my equation in vertex form. I highly suggest from here, pause the video, do it yourself, right? We've done it, we did it all last class. So this is really just a review, but it's just interpreting the word problem, interpreting the graph. So my y value is 30, don't know my a value, x value is 0, h value is 2.5, and my k value is 35. So 30 equals a times negative 2.5 squared plus 35. Negative 2.5 squared is 6.25, so 30 equals a times 6.25 plus 35. You subtract 35 from both sides, giving me negative 5 equals a times 6.25. Divide both sides by 6.25. Giving me negative 0.8 equals a. So here's my a value. So my equation is y equals negative 0.8 x squared. Ooh, sorry, messed up again. This is in vertex form. Negative 0.8 x minus 2.5 squared plus 35. Here I have my vertex, that maximum point. Here I have my a value. But let's not stop there. Let's talk about the domain. What would the domain of this function be? It would not be x is all real numbers. Why not? Pause the video and think, why would my domain not be x is all real numbers? Negative infinity to positive infinity. So domain here, remember, and what is our domain talking about? Domain is talking about the seconds that the ball is relevant for this problem. Can I have negative seconds? No. When did my time start? My time started at 0. So I started with the ball at 0 seconds. And when did the ball hit the ground? Good question. Let's go see. So let's go use Desmos. Let's go graph this equation. Y equals negative 0.8 x to the power of 2. Oops, I keep writing the wrong thing. X minus 2.5 squared and plus 35. So here's my graph on Desmos. You can see here I have the ball. I start off the ball, threw it up in the air. It reached a maximum height at 2.5 seconds, 35 feet. And it hit the ground, bam, right here. And how many seconds was that? 9.114. So it hit the ground at 9.114. So it stopped here. So why? Right? Because my ball didn't go under the ground. So my domain would be 0 is less than or equal to x is less than or equal to 9.114. Well, let's talk about range. Why is my range not everything less than 35? Why is it not y is less than or equal to 35? Well, is it everything less than this point? Even the negative? No. What's the lowest that the basketball was at? 0 feet. What's the highest the basketball was at? 35 feet. So the lowest my basketball was at was 0 feet. And what's the highest point my basketball was at? 35 feet. So my range will be everything between 0 and 35. 0 is less than or equal to y is less than or equal to 35. So we have our domain, we have our range. We know that the vertex represents the maximum height of the basketball. We know that our y-intercept represents the starting point of the basketball. And we know that our zero, our only x-intercept here, represents when the basketball hits the ground. Basketball hits the ground. So what I need you to be able to do, what you're going to be doing on your test and your assignment, is interpreting all these small little things. What does the vertex mean? What does the domain mean? What does the range mean? What does the y-intercept mean? What does the zero mean? All of these things, you need to know what they mean in the context of the problem. Domain is that my ball started at 0 seconds and stopped at 9.114 seconds. My range, my lowest point the ball was at was 0 feet. The highest point was 35 feet. Okay. My y-intercept, the starting point of the ball, maximum height is the vertex, and the ball stopped at 0 feet at 9.114 seconds. Okay. So that 0 was 9.114. So all of this you need to be able to interpret and go from vertex form to standard form. So I know that's a lot. This whole slide looks very messy, but this is exactly what I need you to do for today's assignment. And a whole part of the test is interpreting the whole entire word problem. All right, if you have any more questions, again, I would recommend looking at that Zoom video from last year, and that will help you a ton. Pause the video and try to figure out this word problem. So we have Joshua jumped off a diving board. So here's my diving board. Here's Joshua. And he jumps off the diving board into the water. Right? And the diving board was 20 feet high. So we know that at 0 seconds, he was 20 feet high. After 1.5 seconds, he was 22 feet, and this was his maximum height. So we want to write an equation. So we need to label our stuff. We have our x, our y, our h, and our k. Plug it all in to y equals a, x minus h squared plus k. And I'm going to go fast through this because you paused the video, right? And you did it yourself. Excuse me. So 20 equals a times negative 1.5 squared plus 22. Negative 1.5 squared is 2.25. Subtract 22 from both sides. Negative 2 equals a times 2.25. And divide both sides by 2.25. And that's going to give me quite an interesting number here. Negative 2 divided by 2.25. Let's just get the fraction. Negative 8 over 9 is our a value. Negative 8 over 9 equals our a value. So my equation would be y equals negative 8 over 9, x minus 1.5 squared plus 22. So there's my vertex form. Again, interpret everything. We know that the domain will be from 0 is less than or equal to x is less than or equal to whenever he hits the water. So you're going to have to graph this on Desmos. Y equals negative 8 over 9. X minus 1.5 squared plus 22 at 6.475 seconds. So these are seconds. So this is his starting. And this is when he hits the water. And my range would be 0 is less than or equal to y is less than or equal to 22. This highest point he's at in feet, and this is the lowest point he's at in feet. 0 to 20 feet is my y-intercept, where he started at. Maximum height he reached is at 22 feet in 1.5 seconds, and he hit the water at 6.475 seconds. So my 0 represents when he hit the water. All right. Have a great, fantastic day.